Hi, everyone. Thank you so much for attending today's session. Before I start, I'd like to thank AIChE for organizing this virtual conference in the middle of the pandemic. My name is Akash Majumdar, and I am a project manager at Ingenero here in Houston. Today's session is going to be about data analytics and a roadmap to achieving operational excellence. Let's get started. It's important to understand the magnitude of growth we have seen over the past industrial revolutions. We've seen equipment powered by steam, water, and electricity. Just in the past century, we've witnessed the transition from labor-intensive processes to automation. We've also seen the emergence of IT infrastructure, and today, big data, artificial intelligence, machine learning, and the Internet of Things play a huge role in today's Industry 4.0. All of this applies to the process industry, where advanced analytics and augmented intelligence combine to provide incredible real-time solutions. With this constantly evolving and improving technology, it is key that we leverage these real-time analytical capabilities towards meeting our objectives and answering the questions that help us arrive at an optimal solution. These questions could include, what's the current operational status of our equipment? What are our limitations? Are there different options that we could choose to achieve greater efficiency? We can even delve deeper into specific domains. For example, how do we maintain high yields without compromising on reliability? Specific to our industry, we can even gain insight on equipment run length and its related profitability. These questions can be related to the dynamic environments and optimization challenges that we face on a daily basis in our equipment and in our plants. To understand this, let's take a closer look at 4 common key performance indicators. First, let's talk about throughput. It's always important to look at this KPI, as the optimal process can maximize capacity without affecting the availability. These figures and situations can change, and it is imperative to constantly consider the economics behind it and the resulting profitability. Similarly, we need to look at yield, as the end product to any process is obviously of utmost importance. We need to ensure that we are improving our performance to achieve the best possible yield. It's also dependent on our ability to adjust dynamic benchmarks according to operating conditions. Process controls help us identify deviations and drifts from expected performance and can act as an indicator of controller effectiveness. Finally, reliability is a key concern of any process, as it signals the stability of the process and is a proactive measure to allow operators to predict failures and identify problems before the fact. This can lead to significant savings in the form of reduced equipment downtime and reduced equipment failures. To be able to use all of these in conjunction with each other, it's necessary to take a combined approach. Solutions that we work towards need to use both first principle models as well as machine learning and data analytics. While first principle models can be developed with the use of technical and domain expertise, machine learning and augmented intelligence can constantly improve with the increase in available input data and logic trains. This is created from sophisticated algorithms that automate techniques such as regression, clustering, multivariate prediction, and are also able to create neural networks based on operational logic. Using all of these capabilities under the guidance of domain expertise, we can use our data analysis abilities to create incredibly powerful tools, such as live dashboards, live benchmarking, live simulations of our plants and equipments, and technology such as virtual sensors can even accelerate and improve our ability to forecast. As process industry experts, our jobs are to use all of these functions in a combined approach and then customize it to arrive at a solution that fosters productivity, profitability, reliability, and robust operation. Another major part of these data analytic processes hinges on our ability to replicate our equipment, plant layouts, and process workflow in simulation models, or in short, digital twins. Using real-time analytics, we can maintain the best levels of operational efficiency by using the real-time data, processing it through artificial intelligence-powered algorithms and analytical techniques. Being able to duplicate operations digitally empowers companies to get real-time insights on operational advantages and how to leverage those to increase yield and efficiency, or even potential areas for improvement and where the process is falling short. The ability to track these in real time results in a massive amount of time and effort saved, thus eventually resulting in better operations and more profitability. You can truly achieve excellence through these insights. Moving forward, I'll be talking about how Ingenero is able to leverage these powerful capabilities into real, actionable insights through our customized infrastructure. Ingenero has created a Decision Excellence Engineering process, or DEEP. As I talked about before, it is all about using a combined, customized approach. DEEP uses all of these tools, specialized services, software solutions, and artificial intelligence in combination, powerful results. In today's industry, a majority of players are heavily investing in digital transformation. This is powered by sophisticated data analysis and augmented intelligence. DEEP does just that. It is important to note that this infrastructure has been built on millions of hours of cumulative domain experience. DEEP brings together and digitizes all available structured and unstructured data, processes and analyzes that data continuously using rigorous AI modeling and digital twins, and produces dashboards, reports, and notifications. These allow operations managers to seamlessly integrate digital technologies to monitor their plants in real time and capture the maximum possible value. What's more, this can be done on-premise, remotely via the cloud, or a combination of the two, resulting in a hybrid solution. Let's dive deeper into methodology that allows processes like DEEP to be so effective. The big advantage of this continuous data analysis and processing is that these AI-powered algorithms can process years and years of historical data and analyze current conditions based on the historical data that is comparable. The best operating scenario can be easily hypothesized, and accordingly, a gap analysis can be carried out between current operating conditions and a potential optimal operating set of conditions based on processed and analyzed data. This can be done in real time, which allows for scenario matching between current conditions and historical conditions. These gaps can then highlight opportunities that can be leveraged to create optimal conditions. We can also use historical data to see where past shortcomings have occurred, and then can proactively plan to avoid these using features such as deviation flagging. These changes can result in improvements. This can happen at different levels. Whether you are looking to carry this out on a large-scale overall plant level, a sectional unit, or even down to individual equipment, gap analysis powered by data-driven insights can lead to great operational improvement. It also allows you the flexibility to allow users to set benchmarking targets for performance. In addition, we can use real-time performance trackers to eliminate constraints on our operations. We can track the stability of our operations with stability index deviation tracking. We do this by tracking various operating parameters and smart adaptive data analytics. Any abnormal deviations in these selected parameters leads to an alert to the operations manager. Also, we can track the degree of effectiveness of controller performance. Being able to do this ensures effective control of all processes and enables real-time comparison of critical variables. This, in addition to the ability of the tracker to identify key constraints negatively affecting or even limiting performance, results in a measurable index of performance. Here is a view of Ingenero's evaporator fouling monitoring system. This not only allows real-time tracking of key variables, but can enable these evaporators to consistently perform above their design capacities. You can take a closer look at this dashboard view, and you'll see that you can see key data points that indicate the performance level of this evaporator. For example, in the top left corner, there is a clear indicator of time left before the next boil out within an accepted indicated range. Right next to it, you can see a fouling percentage monitor. The graphs and charts below also show important trends and data lines related to fouling and cleanliness. However, arguably the most important feature you'll see in the screen capture of our dashboard is in the top right corner, where there is a recommendation that is generated with the help of augmented intelligence and data analysis. This is just one example of the intelligent insights that can be derived using data-driven methods such as the ones we use at Ingenero. Just in one view, you get information about predicted run length, historical benchmark comparisons, effectiveness of cleaning, and smart recommendations and solutions. Here are another few views of Ingenero's dashboards as related to furnace run length and reliability. These dashboards show a furnace reliability matrix with predictive analytics. Some salient features from these dashboards are that you can predict the end of equipment runs. You can identify limitations and constraints much faster than a comparable manual process because of the real-time insight and data analysis. You can also identify opportunities for improvement. This insight also helps you better schedule furnace upkeep, runtime, and cleaning, and thereby maximizes your overall capacity to operate given your current setup of equipment. So why should we do all of this? Hopefully, this slide will shed light on the great improvements that can be enjoyed through data analysis infrastructures and techniques, such as the ones used in our deep infrastructure. Using digital twin models and augmented intelligence-powered analysis has empowered Ingenero to massively improve production records for clients over the years. Activities such as daily tracking, digital twin creation, in-depth studies, and overall domain expertise application has led to some extremely favorable results for our clients. These are some that I'm excited to share with you. Using operational improvement in tandem with CapEx and feed optimization, we've had clients experience over 80% capacity growth. Not only that, but examples show that yields have increased, run lengths have been boosted by over 50% over design specifications in some cases. Feed input requirements have fallen by 3.5%, and resultantly, recovery has also improved past benchmark levels. Client plants are being operated at over 105% of design capacity as compared to before, when they were only operating at 89% of design capacity. As you can imagine, such performance improvements bring a quantifiable return and lead to over $100 million of savings. Here are a few more examples of how our work in data-driven operational improvement has resulted in beneficial scenarios for our clients. In a European integrated chemicals company, we spurred a 374 million euro growth through our digital transformation platform, along with a cost and revenue model. We generated $250 million in savings for 2 ethylene facilities of leading US petrochemical majors. In another ethylene facility in the US, we increased production by 6% by enabling a run length improvement that led to surplus operation. We also helped a midstream company in the US operating a NGL pipeline network increase profits by over 20%. As you can see by these examples, our data analysis-driven approach has applications across the industry and across the globe. As mentioned in one of the case examples in the last slide, our digital transformation helps augment operational improvement exponentially. These intelligent software solutions drive benefits that are almost impossible to accomplish using more traditional methods. These analytical strategies help drive substantial economic gains, proactive or timely resolution of plant issues or operational gaps, and in combination with in-depth domain expertise from seasoned experts and customized visual dashboards, empower massive value capture. That brings us to the end of this presentation. Thank you for attending this session once again. My name is Akash Majumdar, and my email, in addition to other contact information, is on this last slide. I look forward to connecting with you. Till then, stay safe and take care.